Okay, Assalamualaikum warahmatullahi wabarakatuh and good day. So today we're going to finish off our array topic by learning about searching and sorting arrays, sorting algorithm. Okay, so it's very common for programs to not only store and process data stored in arrays, but also to search arrays for specific item. Okay, so in this video playlist, we'll be learning about two uh, two methods of searching an array, which is linear search and the binary search. And later we'll learn about sorting arrays. So introduction to the search algorithm. Search means locating an item in a list of information. So in this case, we are trying to locate an item in our array by going through or traversing all the elements in the array. There are two algorithms uh, we will examine, which is the linear search and the binary search. The linear search is a very simple algorithm, also known as sequential search algorithm, and it uses loop to sequentially step through an array. Starting from the first element, it compares each element with value being searched for and stop when either the value is found or the end of the array is encountered. If the value is being searched for is not in the array, then the algorithm uh, will be will continue to search to the end of the array, but will be unsuccessful in finding the item. Okay, for example, we have this array num list with the following elements, and we try to search for the value 11. So linear search will start from the first element, which is 17, and it will compare 17 to the search item, which is 11. If it is a mismatch, then we'll move to the next element of the array num list, 23. A mismatch again, and then it will move to array 5, the next element, which is 5. Okay, mismatch again, then it will move to the next element, which is 11. Now it's a match. So now the linear search will stop and return match and return the location where the match is found. But let's say if you search for the value 7, linear search will start to examine from the first element, which is 17, and it's a mismatch. It will move to second element, 23, mismatch again. 5, the third element, 5, mismatch again. The fourth element, and until the end, it will not find 7 because 7 is not in the array list. So it will continue till the end of the array, and it will return found as false. Okay, so the algorithm for linear search. So first, before we start the traversing, we set our found, the boolean value. Found is a boolean value to false, and then set position to -1, set index to 0. Okay, so while index is smaller than number of elements, okay, and found is false, then it will traverse through, this is the loop, it will traverse through the array element, and it will check for each array element, each index, whether it's equal to the search value or not. If it is equal, so if this is true, then it becomes found equal to true, and position equal it will return the index as the position. Then otherwise, no otherwise, because it's just if, yeah. So then it will add the one value to index and end while. So you notice that this is just one way selection statement. So this only happens if an match occurred, a match is found. If the mismatch, nothing will happen. It will continue to loop. Okay, right. So in terms of algorithm, in terms of coding, you can see here, okay, you can see in our program here, you have array of size 5, okay, and then we use a search list function which will return an integer value, and this search list search through an array. So it will take our array test, okay, uh, and the size, and also the search item. Okay, so the search item here is 100. Okay, so we want to find 100 in this array. Okay, so this is function search list. Okay, same as here. So our constant empty list, because we the array that we pass, we don't want to change anything in it, we just want to search, so we let it become constant. So nothing will be changed from this function, so it will become constant, so to be safe. Okay, so anti-num to accept the size, and anti-val to accept the search value. Okay, and then the algorithm start here. Index equal to 0, position equal to -1, found equal to false. And while index is smaller than num elements, and is not found, then this index, if the list index equal to value, then found true. This is when the match happen, and index plus plus, and then return well, after this finish, it will return the position. Okay, return the value of the position. So you see the position here is -1. So if it doesn't found, it will return -1. So which means, why it return -1? Because -1 is not uh, is not a valid subscript. That is why we return -1. So if we return other value, even 0, you it will be it will be interpreted as element, the first element. So we return -1. Okay, right. So let's run this program. Okay, you earn 100 points on this 4. Oops. So in this case, so so in this example, okay, you will see you did where this is the test array. Okay, so you want to find the test in which this person attained 100 points. So you need to find the 100 inside this test size, this test array. So it's in the element number 4, but in element element 0, 1, 2, 3 plus 1 becomes test 4, because this is test 1, test 2, test 3, test 4. Okay, so basically that's what it does. This is a scenario only, right? So next, the benefit of linear search is that it's an easy algorithm, and your array can be in any order. The disadvantage is because it's slow, because it will go through each and every element. Okay, so if you have 2,000 array of size 2,000, then it will go through 2,000 elements. Okay, next is binary search. So for binary search, it requires an array to be sorted in order. So it has to be in a ascending order. So if you have an array, you have to sort the array first before you can use binary search. Binary search works by dividing array into 3 sections. You have middle element, and element on the side of the middle element, in one side of the middle element and the other side of the middle element, the right hand side and the left hand side. If the middle element is the correct value, then it will just if the middle element is the search value, then it's done. Otherwise, it will go to step 1, using only the half of the array that may contain the correct value. So you will check. Okay, so it will continue step 1 and 2 until either value is found or there are no more elements to examine. Okay, at our binary search. Okay, for example, this binary search on this num list 2 array here, in this example here. So this array is already sorted in ascending order. So let's say you want to find the value 11 here. What happens is the binary search will divide this array into two. So you have 6 elements here. So the middle element will of course be uh, this this element. So we have 0, 1, 2. This is element 3, 4, 5, 6. Okay, so element 3 is the middle. So in this case, if you since we are searching for number 11, so we found the first step is check whether the middle element is the same as the search element. If the same, then it's return found equal to true, and it stop the search and return the position of this element. So if it search for other value like 7, okay, it will start still in the middle element, this element number 3, okay, and it will check 11 equal to 7 or not. No. So if it is not, then it will check again. It will check then if 7 is greater than 11. No, 7 is not greater than 11. So which means 7 must reside on this side. So what it will do is it will take the first element, it will set the middle value as the first element. So the first array half. So you focus on this half. So the middle one would be first plus 1. So this one, the 3. Okay, so then it is 3 is 3 is 3 equal to 7. No. Then you will check again if 3 is 7 is smaller or greater than 3. Yes. So which means that you look on this side. So when you look on this side, okay, so we only have these 5 left, one element left. Remember, it has divided the array here, so only one element left. So it will check this element. So this element 5 is equal to 7. No mismatch, then it will stop, which means that it doesn't found any 7 here. Okay, so this is the algorithm. Set the first index to 0, set last index to the last subscript in the array. Okay, the first index is 0 lah, of course. Set found to false, position to -1. While found is not true and first is less than or equal to last, set middle to the subscript halfway between array first and array last. Just now the 11 there. If array middle equals to the desired value, then set found to true and set position to middle. Else if array middle is greater than desired value, so this is checking if the array middle is greater than desired value. So if 11 is greater than 7, then okay, if array middle is greater than desired value just now, which means that 11 is greater than 7. So which means that the 7 must be on the lower half, on the left hand side. So what happened is it will set the last subscript into the value of the last subscript as middle -1. This one middle was in the third element, 0, 1, 2, 3. So -1 it will become 2. So from 2, okay, so it will start to find the middle. It will go through the loop again. Okay, the while found is not true. Okay, and first is less than equal or equal to last. So set middle to the subscript halfway between array first and array last. So our first is still 0, but our last is now 2. So it's checking from 0, 1, 2 just now. Okay, so it will check. Okay, 0, 1, 2. The middle one is 1, which is 3 just now. So 3 is not equal to 7. So it will check whether 3 is greater than 7. Yes, so if it's greater than 7, so it means it's on the upper half, okay, of the middle point, which is towards the right hand side. So what it happen is it sets first to middle, first the value of